Arithmetic sequences will be covered in this video, and in the next video will be geometric sequences. When we were doing the patterns before spring break, we noticed that you could add and subtract in order to go from one term to the next, and you could also multiply or divide to get from one term to the next. The adding and subtracting is an example of arithmetic sequences, and then multiplying and dividing was an example of the geometric sequences. So I'm going to go through these notes pretty fast because it's pretty straightforward. What you're doing is you're trying to see how you get from one term to the next. So how do I get from the first term to the second term? Well, to get from -3 to 2, I would add 5. Now to get from 2 to 7, I add 5. And I keep adding 5. Now, an arithmetic sequence, you're going to be adding the same number consistently. So you're not looking for a pattern like adding 2, 4, 6, 8. That's not arithmetic sequences. It must be finding or having a common difference every single time. So this one does have a difference of a positive 5 because we're adding 5. And if I were to have been subtracting the same number every time, it would have been a negative. Let's take a look at part B. So how do I get from 4 to 12? And keep in mind we want to add or subtract, not multiply, divide. So if I'm looking for the difference, to get from 4 to a -12, I would have to subtract 8. Now to get from the 12 to the 24, I'd have to subtract 12. I could keep finding the other differences, but honestly, like I said, the difference must be consistent. So this is not an arithmetic sequence. It does not have a common difference. All right, now, part C, taking a look at this, how do I get from 1.9 to 1.2? I subtract 0.7. How to get from 1.2 to 0.5? I subtract 0.7. I'm just going to keep checking it. If I subtract 0.7 from 0.5, I do get a -2 or a -0.2, and then -0.2 minus 0.7 does give me a -9. So yes, this is arithmetic, and its difference is a -0.7. Here, I do see a pattern. I see how the rule would be 11 over n plus 1. So I could write a rule here, but the question is it arithmetic? And the answer is no, it's not an arithmetic sequence. All right, when you're trying to write a general rule, I want you to circle this or highlight it, and when it comes to doing an assessment, you'd want to write this on your note card. It turns out by having a pattern, by adding and subtracting the same number every single time, we could write any arithmetic sequence like this. So that helps because when you have a whole bunch of terms, and I say, hey, find the 120th term, you don't want to add 120 times. You could just plug in 120 for n and find out what it is. Now, we're not going to do anything crazy like that, but we will find the 10th term using this rule. So it says this is an arithmetic sequence, so let's see what the difference is. 32 to 25, 25 to 18. So it looks like what we're doing is we are subtracting 7 every single time. So the difference is a -7. I wanted to find a sub 10. So I'm just going to plug in all my information. A sub 10 is equal to a sub 1. That's my first term. That's a 32. Plus n minus 1. So n was 10. 10 minus 1 times the difference, -7. So I just took everything and I plugged it into the rule. That gives me 32 plus 9 times -7. And really, that's 32 times 63. And that would give me a -31. All right, for the next one, we're going to find the 11th term instead of the 10th term. It's going to be the same exact process. You just plug it all in. So let's see. I'll do A with you, and I think you'll be good to... Actually, this one's harder. I'll do this one with you. I'll do B, and then you'll try A. If I'm trying to see if it's an arithmetic sequence, I need to know how to get from this term to the next. So to go from 9.2 to 9.15, that's a smaller number, so I know I'm subtracting. And I'm just subtracting 0.5. Actually, even smaller than that. Whoops, 0.05 is what I meant to put. So each time I'm subtracting 0.05. When I plug it into the rule, if I want to find the 11th term, it's a sub 11 equals a sub 1, that's my first term, 9.2, plus n, which was 11, because I'm finding the 11th position, minus 1 times d, the difference, so a negative 0.05. That gives me 9.2 plus 11 minus 1 is 10 times negative 0.05. That's 9.2 plus, if you multiply something by 10, it moves the decimal place over. So this is actually plus a negative 0.5, or that's 9.2 minus 0.5, which is 8.7. So sorry, I didn't recognize you couldn't see it. So that means that this term right here is 8.7. All right, at this time, I'd like you to try part A. So go ahead and pause the video, and when you're ready to check, you'll hit play. And then if you're all done, that's the answer. You should have gotten negative 23. You are good to go ahead and begin your homework.